In today's video, we'll be learning about the drugs acting on the central nervous system. So in this category, the first class of drugs are sedatives and hypnotics. So by seeing this wallpaper, you might be feeling what is the structure of beard doing over here. So we will understand all these things in the coming slides. So let's begin our topic. So what are sedatives and hypnotics? These sedatives and hypnotics are non-selective or general depressants of the central nervous system. So they are used to induce sleep or sedation in conditions like insomnia. So people who are unable to sleep for the required amount of time, or people who are facing sleep issues, it is known as insomnia. So they are generally given to induce sleep or sedation. And coming to the classification of sedatives and hypnotics, they can be mainly classified into barbiturates, benzodiazepines, non-barbiturates and non-benzodiazepines. That means the drugs which don't belong to either barbiturates or benzodiazepines. Now coming to barbiturates. So two types of naming system is there for this barbiturates. So generally they believe that it is named after the parent compound barbituric acids. So these barbiturates are the derivatives of a compound which is known as barbituric acid. And another nomenclature is barbiture means in Latin beard like. So gents or boys have beards. So the structure of beard is like this. Now when you see the structure of this barbituric acid also, you can see how it is resembling. So this double bond over here and this below structure also. So appearing similar like a beard. Okay, so that is why they are also known as barbiturates. So based on the parent compound as well as the structure of beard, they are known as barbiturates. Now coming to the classification of barbiturates. Here we have four different types: ultra short acting, intermediate acting and long acting. Ultra short acting means the duration of action for these compounds can be from anywhere from few seconds to 30 minutes. Generally they are given as adjuvants, that means along with another or other anesthetic agents to induce anesthesia in surgical conditions, that means in operations. For example, thiopental. So this thiopental, it is given along with other anesthetic agents to induce anesthesia in patients during surgeries or operations. And next we have short acting. In short acting, the duration of action may last up to 2 hours. Generally, they are used as sleep inducing hypnotics. That means they are used to induce sleep. For example, pentobarbital. Next is intermediate acting. So in this, the effect may last from 3 to 5 hours. And these compounds, they have hangover effect. That means after the duration of action is over, people have a certain hangover effect or headache feeling or dizziness feeling like that. So the compound here is MOA. And next we have long acting barbiturates. For these, the duration of action is more than 6 hours. So these are effective sedative hypnotics, and at lower doses they can also be used as epileptic agents. So here phenobarbital is a long acting barbiturate. So based on their duration of action, that means for how long they are acting, they are divided into these four different classes of compounds. And another point over here is barbiturates. Previously, they were very extensively used to induce sedation or hypnosis, but now they are majorly replaced by the benzodiazepines, which are more safer than the barbiturates. Barbiturates, they produce CNS depression by acting on the GABA receptor. Now coming to the mechanism of action of barbiturates. So barbiturates, they potentiate the action of the GABA receptor, that is the gamma aminobutyric acid receptor. So the GABA receptor is a inhibitory neurotransmitter. So what happens here is when these barbiturates, they come and attach to this receptor, here this chloride ion channel. So you can see a channel passing through this receptor. So this is chloride channel. So what happens is the chloride ions enter into the cell. So when these barbiturates, they come and bind to this receptor, this GABA receptor opens and the chloride ion channel opens. As a result, all the chloride ions, they will enter into the cell, and as a result the cell gets hyperpolarized and it causes decreased excitation. So the excitation decreases because GABA is a inhibitory neurotransmitter. So these barbiturates coming and binding to the GABA receptor further increases or potentiates the effect of GABA. That means the inhibitory action is potentiated. The inhibitory action is further increased. So the entry of the chloride ion channels also further potentiates the effect of GABA. So the cell gets depressed. So as a result, presynaptic as well as postsynaptic inhibition takes place. So the greater the affinity of the barbiturates, the greater the potency. So this is the mechanism of action of barbiturates. So the barbiturates, they come and bind to the GABA cell. As a result, the chloride ion channel opens and the chloride ions enter into the cell and the cell gets hyperpolarized. As a result, presynaptic and also postsynaptic inhibition takes place. That is how they potentiate the effect of GABA. Next, coming to the SAR, that is the structure activity relationship of barbiturates. So this is the structure of barbituric acid. So you can give the numbering from this nitrogen: 1, 2, and this one is 3, this is 4, and this is 5. So the position 5 has the major effect of activity. So whatever substituent you are replacing or substituting at this position 5, it greatly influences the activity of these barbiturates. So the action of barbiturates mostly is influenced by the substitution at position 5. So for maximum activity, you need substituents at position 5. So if you increase the length of the alkyl chain of the substituents at position 5, it increases the potency up to 5 to 6 carbons. So the substituent, it can have more than up to 5 to 6 carbons, then you will have depressant action. And if you increase the number of carbon chain length, what happens is you get convulsant action. So this is because of increased lipophilic character. Okay, and next, if you substitute with branched cyclic or unsaturated chain at this position 5. So here in this position 5, if you are including branched cyclic or unsaturated chain, it results in shorter duration of action. That means you will get ultra short acting or short acting barbiturates. Next, compounds having alkyl groups at position 1 and 3. Position 1 and 3 means, so they are nitrogens. So if you substitute these hydrogens which are attached to this nitrogen, then you will get shorter onset and shorter duration of action. This is also because of increased lipophilicity only. And next, replacement of oxygen by sulfur at position 2. So here this is the position 2. So if you replace this oxygen at position 2 by sulfur, what happens is the onset and duration of action decreases, so shortens. So the thiobarbiturates. So if you replace the oxygen with sulfur, you get thiobarbiturates. So these thiobarbiturates, they have rapid onset and short duration of action. This is due to more lipophilicity, which helps in rapid penetration into the CNS and also easily prone to metabolic attack. So this replacement with thio or sulfur group results in shorter duration of action as well as easy hydrolysis. So it is easily prone to hydrolysis. So that is why the duration of action is reduced. So faster onset and faster uh, relieving also. And next, the number of carbon atoms that are present at substitution 5 are related to their duration of action. So as I previously mentioned, so if you increase the carbon chain length from 7 to 9, they have rapid onset and shorter duration. So again, this is also because of increased lipophilicity. Because if you are increasing the number of carbon lengths, what happens? The lipophilicity increases. So they get rapidly distributed into the CNS, and again they are easily hydrolyzed also. And next, if you replace with 5 to 7 carbon atoms, you get intermediate acting barbiturates. And compounds with polar side chains having 4 carbons or ethyl groups or presence of ethyl and phenyl groups results in slow onset and longer duration of action. For example, you have phenobarbital. So phenobarbital, it is having a phenyl group and also an ethyl group. So what happens here is the onset is slow and the duration of action is longer. So if you have compounds with polar side chains, what happens? There is slow onset and longer duration. That means you get long acting barbiturates. Okay, so these substitutions are at position 5 for the barbituric acid. Okay, so this is about the structure activity relationship of barbituric acid or barbiturates. So in this video I have explained about what are sedatives and hypnotics, what are barbiturates, their mechanism of action as well as their structure activity relationship. I hope the video was informative. So if you like the video, do not forget to share and subscribe to my channel. We'll see you in the next